The cosmos inside an onion skin. Chapter 2. Art, Science, and Religions. The three pillars of human knowledge.
Hello, my friends. Before we continue our journey through physics, I would like to reflect on something even more fundamental. I believe that 60 to 70% of all the problems in the world are, at their core, caused by communication failures. And even when the problem has other causes, things get worse because people just can't understand each other. So if we could overcome these communication problems, our world would be a far better place to live in. But how do we solve a communication problem? And in fact, how do we solve any kind of problem? If you have an issue in a system or a equipment, how can it be fixed? Take a simple example. You try to leave home. But your car won't start. Most people call a mechanic. And he can fix the car since he understands how the engine works.
The first step to solving any problem is understanding in detail how the system works. This is true for car engines, and it applies equally well to communication systems.
Communication systems.
A basic communication system consists of three essential parts: a transmitter, a receiver, and the communication channel that carries the information between them. The transmitter encodes one message and sends it through the channel. The receiver reads the signal, decodes it, and recovers the original message. In a basic communication system, we can also find a few variations. Different types of channels, different architectures, and different timing behaviors. And a channel can be unidirectional, where the message travels only in one direction. Or it can be bidirectional, where messages go back and forth, and transmitter and receiver constantly switch roles. In some bidirectional systems, like amateur radio, messages can collide when two people speak at the same time. But in most bidirectional channels, like computer networks, messages flow both ways without collisions. The architecture of a communication system can also change from the basic transmitter-receiver model. A single transmitter may send the same message to multiple receivers, something we call broadcast. But the opposite, many transmitters sending to one receiver, doesn't form a single architecture, because in this case, the messages are independent, forming separate systems. Broadcast can happen through parallel channels or a hub that distributes the message in a star-shaped network. We can also have a daisy chain configuration, where each device receives the message and forwards it to the next. Another variation is hierarchy. A system can operate in a master-slave model or in a multi-master model. In a master-slave model, only the master initiates the communication, just like when we interact with ChatGPT. In a multi-master system, everyone may speak. But when the channel can suffer collisions, a symbolic token can be used to decide who will speak next. Like radio operators, who end their message by saying, "over," signaling that they've finished, so the other person can talk.
It's very hot here today, over.
It's also hot here in the afternoon. I'm going to the beach. Over.
Hopefully it won't rain. I'm leaving now. Over.
Communication can also vary in time. Some systems work in real time, and the message is received immediately. Others involve delay. The message may take minutes or even hours to be read, as in email or messaging apps.
This message is urgent. I hope Peter reads it now.
I won't read this now.
This part of the book is really interesting, and Eve always sends some nonsense, but I'll check it later.
And there is a third case, communication where the delivery time is undefined. This happens when we send a broadcast message without knowing if anyone will receive it. Publishing a video works exactly like this. We release the message into the world, and it simply waits for receivers.
I hope at least one person watches this video and understands what I'm trying to say.
Symbols and semiotics.
To understand the communication process, we need to see that every message carries symbol inside it. But what exactly is a symbol? People usually know what a symbol is instinctively. For example, look at this image. This image is a symbol? Yes, we can clearly see that this is the symbol for fragile, right? And this next image? Obviously, this is a question mark, which is also a symbol. And now, what about this image? It's easy to see that letters, numbers, and mathematical operators are all symbols as well. But what connects all these symbols? How can we actually define what a symbol is? Can we define symbols simply as things drawn on a piece of paper? But if that were true, then even this image would be a symbol. It's a nice drawing with many elements forming a landscape, but it is not a symbol. So maybe a symbol must be a simpler image, made of just a few lines with a clearly defined shape. If that is true, then are the shapes in this image symbols? You probably answered no, but why are these shapes not symbols? These shapes are some kind of tattoo or ornament, and they may look like symbols, but they don't mean anything. The truth is, symbols are very important, but defining them is not easy. In the late 19th centuries, a philosopher named Charles Peirce created a field dedicated to the study of symbols. Peirce called this new philosophical area the field of semiotics.
Every symbol exists within the semiotic triangle.
Here we can see that the symbol is made of three parts: the interpreter, the sign, and the meaning. The sign is the visible physical form of the symbol, the part that carries the information. It is an image, but it can also be a sound or even electrical signals traveling through a wire. The interpreter is the one who observes the symbol. And the meaning is what the symbol represents inside the interpreter's mind. Note that if any one of these three elements is missing, the symbol simply stops existing.
Let's look at this more closely, using the fragile symbol as an example. The sign is the drawing of a cracked wine glass printed on a piece of paper. And the interpretant is the person who looks at the symbol placed outside the box. And the meaning is there is something inside the box, like a glass or a lamp, that can break.
This symbol indicates that inside this box there is something delicate that can break.
And symbols can combine and create symbolic words, which together become symbolic sentences. Now consider the symbolic word banana. For a human, it evokes the image of the fruit. But if you show this to a monkey, it means nothing. The symbol is gone, as there is no interpretant. And before they were deciphered, Egyptian hieroglyphs weren't symbols, only carvings with no interpreter. And a word with no meaning carries no interpretation, and therefore is not a symbol at all. But this strange word might exist in another language, and for the right interpretant, it would be a symbol. Note that symbolic words can also replace visual symbols. For example, the symbolic word fragile can replace the cracked glass icon. And so, a compact set of basic symbols can represent all other symbols. Old telegraph messages worked like this. They used only letters and spaces. The punctuation marks were expressed using abbreviations like VG for comma, while other symbols had to be written out by name. Morse code goes even further. It uses only two symbols, dot and dash, to define all letters from A to Z. In telegraph communication, people wrote a message that was sent using a manual key. Short touches became dots, and longer touches became dashes, which will form the letters. These electrical signals traveled through a wire that could be hundreds of kilometers long. On the other side, a person heard the beeps emitted by a speaker and wrote the letters on paper. Or a machine received the signal and printed recovered letters onto a continuous paper tape. The message was then typed, sealed in an envelope, and delivered to the recipient's door.
Peter, message from your brother. Daughter born. Name Anna Brown.
In the communication process, there is an additional point to consider. The responsibility for successful communication always lies with the transmitter. It is the transmitter's duty to ensure that the receiver understands the symbols and concepts being used.
And so we can prove our hypothesis.
I didn't understand anything he explained. If the transmitter uses ideas the receiver does not know, the failure is not the receiver's. It's a failure on the part of the transmitter, because it should have defined these concepts first.
And these are the basic concepts we're going to use.
Professor, I understood all of this easily. You can continue.
Realm of ideas.
Now that we understand symbols, we can move forward into the realm of ideas. Simple symbols and symbolic words carry a meaning that arises in the mind of the interpreter. And sets of symbolic words form symbolic sentences that can express basic ideas or atomic ideas. For example, even if individual words make sense, the sentence, cake, hammer, moon, elephant, this sentence is not a symbolic phrase because it does not contain an atomic idea. But the symbolic phrase, the cake is sweet, clearly contains one atomic idea. And also, this atomic idea can be expressed in many languages, such as o bolo é doce in Portuguese. And symbolic phrases can contain several interconnected atomic ideas, forming a complex idea.
Perfect communication.
Now that we understand what symbols are, we can return to the essence of communication. In the basic case, both the transmitter and the receiver contain interpretants. Before sending a message, the transmitter interprets its own symbols and assigns them meaning. Then the message travels through the channel, and the receiver reads it and interprets the symbols. If the receiver's interpretation match or come very close to the transmitter's interpretation, this is the case of a perfect communication. But if the meaning for the receivers diverges from the transmitter's meaning, the communication fails. And the greatest cause of communication failures is not noise nor transmission errors. It is the fact that transmitter and receiver assign different meanings to the same symbolic phrases. And so this divergence in meaning, this is the true root of most human conflicts.
Organization of human knowledge.
This concept of communications, ideas, and symbols allows us to organize human knowledge. Note that when an interpreter receives a symbolic sentence, he not only understands the complex idea, but he also assesses whether this complex idea is true or false. When it does not matter whether a complex idea is true or false, we are in the domain of art. And also, when a set of complex ideas is considered true, we have two possibilities. If these ideas are considered absolute truths or dogmas, we are in the domain of religion. But if the ideas are considered provisional and changeable over time, we enter the domain of science. Sets of complex ideas, divided into three major domains: art, religions, and science.
Domain of art.
We often describe the arts as separate areas: theatre, dance, music, cinema, painting, and literature, gastronomy, sports, video games, and even fashion can also be considered within the domain of art. But art is not concerned with truth or falsehood, only with emotional or aesthetic impact.
Art allows for fiction, invention, metaphor, and creativity without any conflict. Because in art, factual truth is not required.
Domain of religions.
Religion, on the other hand, organizes complex ideas as fixed truths or dogmas that cannot be changed.
Normally, religious dogmas are defined by a master who received these ideas directly from God.
I am a Christian, and I accept the absolute truths left by Jesus Christ.
God is our Father, and all people who are His children are brothers and sisters.
And because of this, a dogma cannot be questioned or modified.
I am a Muslim, and I accept the absolute truths revealed to the Prophet Muhammad through the inspiration of Allah.
There is no God but Allah, and Muhammad is his messenger.
I am a Buddhist, and I accept the truths taught by Siddhartha Gautama, the Buddha.
The origin of human suffering arises from our attachment to things that are entirely impermanent.
For this reason, different religions can come into conflict, as each believes it possesses the only absolute truth.
I am a flat earther, and I accept the absolute truth left by Samuel Rowbotham, that the earth is flat.
And NASA's photos of a spherical Earth are as fake as NASA's photos of the moon landing.
Domain of science.
Science, in turn, organizes complex ideas as provisional truths, what we call paradigms.
The goal of science is to construct models that describe and predict the behavior of the universe. When a new paradigm explains more phenomena with fewer assumptions or greater coherence, science undergoes a paradigm shift. The old paradigm is preserved in its historical context, while the new one is adopted. That is why scientific knowledge can evolve without destroying the paradigms that came before.
Because scientific truths are provisional and evolve over time, there are very few real conflicts between scientific fields. Just as in the arts, divisions are created to organize knowledge, but in essence, there is only one science. In this sense, modern science is seen as a continuous evolution of Greek, medieval, and Renaissance science.
Every civilization stands on a three-legged stool: science, art, and religion. Like any real stool, the three legs must be equal in size, connected, and in harmony. Ancient Egypt achieved extraordinary results precisely because these three areas were balanced. One example is the Great Pyramids. They had religious purposes, relied on advanced science, and were works of art. And so the pyramids of Egypt, built more than 4,000 years ago, still stand today. In ancient Greece, philosophers were the first scientists and lived in harmony with the gods and the arts. In modern society, unfortunately, this balance no longer exists. We now sit on a distorted stool, shaped by historical conflicts between science and religion.
The science won this conflict, promising prosperity and progress for humanity.
But by imposing a materialistic worldview, it created a lasting imbalance among the three legs. Now the scientific leg has grown so large that our civilization is unstable and at risk of falling. And so, how long our modern civilization, built upon a materialistic scientific foundation, will endure?
Paradigms are supported by dogmas.
The standard discourse among scientists is that science is composed solely of logical, precise, and well-founded paradigms. However, a fundamental problem arises. This discourse is wrong because sets of paradigms cannot stand on their own. Paradigms must ultimately rest upon a basic dogma or upon a chosen dogma.
Philosophy.
In the scientific field of philosophy, these basic dogmas are referred to as hypotheses.
Philosophers deal with hypotheses, ideas they assume to be true as they seem fundamental. These are basic and obvious ideas. But accepting them as true is an act of faith.
It is not a religious faith, but a faith in the vision of a great thinker or philosopher. Using a set of hypotheses and some logic, philosophers can build entire systems of thought. But since this logic can be rethought, given another deduction, it is provisional truths or paradigms. Because philosophy contains elements of faith at its foundation, it resembles religions. Usually, the philosopher who creates the hypotheses is revered almost as a sacred figure. And the school built upon those hypotheses often takes the philosopher's name.
Another similarity with religion is that philosophical schools rarely agree with one another. As a result, there is no single, unified philosophy.
And different philosophical schools rarely accept the ideas and hypotheses proposed by other philosophers.
Mathematics.
Mathematics is another scientific field that uses many basic dogmas, which are called axioms. These axiomatic dogmas are truths accepted without proof, usually proposed by a great mathematician.
All areas of mathematics are based on axioms, which are absolute and immutable truths.
And so axioms can be classified as scientific dogmas because they are not based on religious faith. To understand how axioms work, we can observe the simplest area of mathematics, the field of arithmetic, which is based on only 3 axioms. The first is the axiom of equality,
which essentially states that quantities exist.
These quantities may be complex objects or simple figures such as circles, triangles, and polygons. A quantity can be associated with a numerical symbol by using the equality sign. For example, the letters I and V represent 4 in Roman numerals, and the sequence 1, 0, 0 represents 4 in the binary numeral system. The second axiom is the axiom of succession, which we will represent by the letter S.
This axiom is divided into 2 parts. The first is that all sequences begin with 0. Because the number 0 represents the absence of elements, or an empty set. The second part is the function S itself, defined by the inclusion of a new unit to a given quantity. Thus, S of 0 is equal to 1, S of 1 is equal to 2, and S of 23 is equal to 24. Note that this is not fixed. In Roman numerals, S of I is equal to I, and S of I, meaning the number 3, is equal to I Earth of V, meaning the number 4. Similarly, in binary notation, S of 1 is equal to 1, 0, and S of 1 is equal to 1, 0, 0. That is 4 in binary. The third axiom is the axiom of addition, which is also divided into 2 parts. The first part is, any number added to 0 is equal to the number itself. The second part is, if one number is represented by the letter A and another by the letter B,
then the value of A plus S of B is equal to S of the value obtained by adding A to B. This seems difficult, but it isn't. For example, using the numbers A equal to 3 and B equal to 5. Applying this formula shows that the value of 3 plus S of 5 is equal to S of 3 plus 5.
Since S of 5 is equal to 6, adding 3 results in 9. Since 3 plus 5 equals 8, and S of 8 equals 9. And so, it is easy to see that this axiomatic equation is valid. Now that we have these 3 basic axioms, we can construct the complete field of arithmetic. For example, to determine the value of 1 plus 1, we note that 1 is equal to S of 0. Thus, 1 plus 1 is equal to 1 plus S of 0.
Now, applying the axiom of addition with A equal to 1 and B equal to 0, we obtain that
1 plus 1 is equal 1 plus S of 0 and also is equal to S of 1 plus 0. Since 0 does not affect addition, this becomes 1 plus 1 equals S of 1. And since S of 1 equals 2, we obtain the result that 1 plus 1 equals 2.
But teacher, why do we need to do all this to prove something so obvious, like 1 plus 1 equals 2?
It was necessary because mathematics accepts a small number of axioms as absolute truths. But in arithmetic, everything else must be deduced from these 3 basic axioms.
Ah, I understand. From what we have just seen, we can generate all the other sums.
Exactly. And from this, we can also easily deduce multiplication and exponential.
And what about inverse operations, like subtraction and division?
These can also be deduced easily, as well as square roots and logarithms.
1 plus 1 equals 2 is so obvious. Isn't that also an absolute truth?
This result was deduced, and so it is a paradigm, a truth that can change over time.
How is that possible? Can 1 plus 1 actually be different from 2?
Yes, a paradigm can cease to be valid over time, or when the context changes. For example, in the binary numeral system, S of 1 is equal to 1, 0. As 1 plus 1 is equal to S of 1, this means that, in the binary numeral system, 1 plus 1 is equal to 1, 0.
Thus, in arithmetic, 3 basic axioms create the foundation of the entire field. However, all these deductions are paradigms, provisional truths that are not always valid, because they can change depending on the numeral system.
Because each branch of mathematics is defined by its own consistent axioms, there is no conflict. Mathematics is divided into several areas, such as arithmetic, calculus, geometry, set theory, and probability. However, there is a single and cohesive field known as mathematics.
Science and physics.
In modern science, particularly in physics, we have 2 fundamental dogmas. The first is Occam's razor, which states that the simplest explanation is to be preferred.
William, do you believe that man can understand the universe that God created?
Yes, but is there a problem? Yes. For this to happen, we need to use a razor of ideas. What do you mean?
This razor cuts hair. A razor of ideas cuts away wrong ideas.
I believe that God created this universe based on logic, mathematics, beauty, and art.
So we can create theories that try to explain how our universe works, but...
But is there a problem?
We observe effects, and we need to deduce the fundamental causes.
Is that an issue?
The same effect can have several valid and different causes.
But they cannot all be true.
That's exactly where my razor of ideas comes in.
Can you explain this better?
We can select the best theory based on its simplicity, mathematical beauty, and elegance.
For these were the very criteria God used when creating our universe.
Can you give an example?
3 monks went to the river. On the muddy bank, they saw animal footprints.
The first monk said, "A rabbit passed by here." The second monk said, "A boy pressed a spoon into the mud and made these footprints."
The third monk said, "A little devil with feet like a rabbit passed by here."
Everyone explains the origin of the footprints, but only one can be right.
Yes. Applying my razor of ideas, the truth is that a rabbit passed by, because it is the simplest theory.
Now I understand. Thank you for the haircut, and for the cut of ideas.
The second is Galileo's scientific principle, based on the belief that phenomena repeat across time and space.
"4 seconds at this inclination."
Antonio, why do we repeat the same experiment so many times?
"I don't know, Master."
Because I believe that the same configuration produces the same result every time.
That I understood. But what if someone repeats it next year?
Or in another city. Then they should obtain the same result. I believe God created a beautiful and organized universe.
What do you mean, Master?
That things are not random. If the same causes exist in the same context, the same effects will occur.
But if this is so obvious, why do experiments?
Because we cannot rely only on logic or on God's design.
To understand the universe, we must perform experiments systematically and repeatedly, and build good logical and mathematical models of how it works.
And how do we know if a model is good?
A good one explains all observed results. And a good model can also predict the results of future experiments.
So a good model can propose new tests and also predict their behavior?
Exactly, Antonio. And upon the foundation that I am proposing now, a new science will be built.
It assumes that what is true here on Earth must also hold elsewhere, for example, in the Andromeda Galaxy. And also that what was true millions of years ago must still be true today. It is an act of faith to assume that the universe is coherent and operates on simple and elegant foundations, describable through mathematical formulations, and a faith that these formulations repeat themselves consistently across time and space. But scientists rarely admit this, because there is a historical shame in having the foundations of science associated with acts of faith or dogmas.
Paradogmas.
Modern science avoids dogmas and uses paradigms, yet it completely ignores a third, crucial category. I discovered this third category over the years, and I gave it the name paradogmas. No one admits this, but some ideas in modern physics have become so complex that very few scientists truly understand them. And because they were introduced by idolized figures, such as Albert Einstein, certain pillars of modern physics have become untouchable and unquestionable, and turning some basic paradigms of modern physics into paradogmas. For example, the existence of 4 forces and the relativity of space-time are 2 major paradogmas. It is important to note that paradogmas block scientific progress because they cannot be questioned. Any work that challenges paradogmas will not be published in journals because no one will accept it. To illustrate how paradogmas cannot be challenged, consider this historical example.
Hello, Doctor. How are you today? I'm doing well, but I've been feeling a little lonely lately, as my work consumes all my time. I've heard about your work on unification. Yes, I am trying to create a unified theory, a theory of everything that exists.
But some people say that you are using only two forces in your new model.
Is that true? My new model uses only the gravitational force and the electromagnetic force. But what about the strong nuclear force and the weak nuclear force? In my unified model, the nuclear forces are unnecessary.
Hi, Donald. I'm so glad you could come. I have some interesting gossip to tell you.
How was your visit with Albert?
He's in good health, but working very hard.
And what about his new theory?
It won't amount to anything, just wasted time.
Why?
He's trying to unify everything, but he only used two forces.
That's absurd. To unify everything, he needs to use the four forces? Exactly. And he was such a brilliant man until today.
Yes, but now...
Yes, it seems that even genius men, like Einstein, risk becoming senile as they grow old.
At the end of his life, Einstein was considered senile for trying to create a unified theory using only two forces. As a result, Einstein's unification research was abandoned, and it is largely ignored today. But I believe Einstein was right, and in this series I present a continuation of his work. Using a strong gravitational contact force as an alternative to the nuclear strong force.
Conclusion.
Now we can return to my initial question. How can we avoid communication problems? The answer is simple. Ensuring that the transmitter and the receiver share the same meaning. That is why I created this video, to begin presenting concepts of symbols, ideas, paradigms, and so on.
Building a bridge.
Human knowledge is organized into science, religion, and art, the three pillars that sustain all civilizations. And so, for our civilization to continue in the future, science, religion, and art must be integrated. These areas must act in harmony, with science admitting that it does not know everything. And science must acknowledge that something else can exist beyond the material universe. The purpose of my life is to build a bridge between science, religion, and art. In this way, this series is the first pillar of my bridge. A pillar at the frontier of science, which we will build together. Thank you for your attention, and I hope you enjoyed this series.